Yes, dear students. So, today we have to discuss the numerical problems on the chapter atoms. As you know that in our previous class, I was explained about the complete theoretical aspect of this chapter atoms, and now I am going to proceed the numerical problems on this chapter. So, as you know that we came across so many mathematical equations. Say for example, the first mathematical equation we came across is the distance of closest approach, that is d is equal to 1 by 4 pi epsilon naught z e square divided by k, where k is kinetic energy, z atomic number, e charge of the electron. So, d is distance of closest approach. And even we came across about the expression for impact parameter, that is b is equal to d by 2 cot theta by 2, where d is distance of closest approach. So, theta is scattering angle. So, like that, not only these two equations, apart from these two, we also studied about the total energy relation of the electron. So, derived from the Rutherford's theory, that is E is equal to minus z e square divided by 8 pi epsilon naught r. So, this is also another one expression for energy of the electron in terms of Rutherford's atomic theory. And in the same way, while explaining Bohr's atomic theory, we came across about quantization of angular momentum equation, L is equal to mvr, which is equal to nh by 2 pi. In the same way, we came across about the emission of energy or radiation emitted when electron makes a transition from higher orbit to the lower orbit. At the time, energy of the emitted radiation is equal to what? That is energy difference between final and initial states. E2 minus E1 is equal to h nu. E2 minus E1 is equal to h nu. So, next, where nu is frequency of the radiation emitted, E2 energy of the higher energy state, E1 energy of the lower energy state. So, next we came across about the radius of the nth stationary orbit equation. So, expression for radius of the nth stationary orbit of an hydrogen atom, and even we came across about orbital velocity of the electron in an nth stationary orbit, and we came across about total energy equation for the electron in an nth stationary orbit, and even very simple formula for calculating wavelength, that is wavelength of the spectral line 1 by lambda is equal to r into 1 divided by n1 square minus 1 divided by n2 square, a common Balmer empirical formula for calculating the wavelength of the spectral lines of hydrogen atom. And even we came across about nu bar. What is this nu bar? It is wave number. So, that wave number is equal to reciprocal of wavelength. So, therefore, so that nu bar is nothing but what? 1 by lambda. So, this 1 by lambda is nothing but what? R into 1 divided by n1 square minus 1 by n2 square. So, this is also a very important here. So, and also wave number equation we came across, and wavelength of the spectral line. So, these many equations we got to know already in this chapter atoms, and apart from this, some basic concepts are also dealt in connection with the concept of angular velocity, angular frequency, and time period of the orbital motion. So, like that, so we shall proceed all the conditions, we shall proceed with the help of all the equations, the numerical problems one by one. The first problem of this topic I would like to discuss is calculate the orbital velocity. The problem number 1, they are asking you the question. So, please, I am going to read the question here. If possible, you try to note down it, and even I am going to write that in a shortcut method on the board. So, I can't write whole question on the board. So, I will write what are the given quantities, what is the given data, and what we supposed to calculate. So, that thing I am going to highlight on the board. So, just you can go through that, and if possible, if you are available with the book means, then it is well and good. So, if you can go through the textbook for referring the numericals dealt with this chapter atoms. So, one by one, the first problem is calculate orbital velocity. So, they are asking you calculate orbital velocity. So we have to calculate here orbital velocity. And frequency of revolution, they are asking you to calculate frequency of revolution of the electron in the second orbit of hydrogen atom. They are asking you to calculate this in the second orbit of hydrogen atom. It means n is equal to 2. Hydrogen atom, if the radius of the first orbit is, they are giving the radius of the first orbit is 0.53 angstrom. So they are giving the data here 0.53 into 10 raised to minus 10 meter. Very simple problem. Calculate orbital velocity of the electron and frequency of the electron where? In the second orbit of hydrogen atom. The given data is what? R1 is equal to 0.53, that is angstrom, that is 0.53 into 10 raised to minus 10 meter. So how to calculate? So they are asking this for what? Hydrogen atom. So obviously if it is hydrogen atom, so we have to consider atomic number 1. Then recall the equation for orbital velocity. What is the expression for orbital velocity? We know that orbital velocity is equal to 1 divided by n into z e square by h epsilon naught. So 2 h epsilon naught z e square divided by 1 divided by n z e square by 2 h epsilon naught is nothing but the what equation for orbital velocity of the electron in an nth stationary orbit. So here n is given to h Planck constant we require here. Okay, fine. Epsilon naught also require here. Z is 1. That is clearly 1. E charge of the electron we have to take. So therefore here still more data I have required, that is Planck constant 6.625 into 10 raised to minus 34 joule second, and even value of E 1.6 into 10 raised to minus 19 coulombs, and even the value of epsilon naught 8.854 into 10 raised to minus 12. The value of epsilon naught is 8.854 into 10 raised to minus 12, the value of epsilon naught. So that is 8.854 into 10 raised to minus 12 epsilon naught value. That is so this is Coulomb square per Newton per meter square. So epsilon naught is given. The first problem is very simple. Calculate orbital velocity of the electron as well as frequency of the revolution of the electron in a second orbit. For this, they have given radius of first orbit is 0.53 angstrom. So 0.53 into 10 raised to minus 10 meter. So how to calculate orbital velocity? So we know that orbital velocity V is equal to 1 by n into z square by 2 h epsilon naught. I have every values here, just you can substitute. Therefore, V is equal to orbital velocity V is equal to, so I can write this as z e square 2n h epsilon naught. So here z is 1, charge of the electron 1.6 into 10 raised to minus 19 whole square, and even divided by 2 into n, that is 2 only because second orbit, into 6.625 10 raised to into 10 raised to minus 34 into this epsilon naught value 8.854 into 10 raised to minus 12. See, one hydrogen atom, E charge of the electron, n orbit number 2, that is 2 h epsilon naught. So therefore h value and epsilon naught. First, always I told you, wherever the numericals will come, so at the time first you simplify the powers. So this step can be written as 1.6 whole square. So what is 1.6 whole square? You try to find it, and 10 power minus 19 whole to the power of 2, that becomes what? That is 19 2s are 38. So that you have to do. So just you simplify this powers and powers of numerator as well as denominator, and final answer you will be find out for V is, you are getting, after simplification you are going to get the value 1.094 into 10 raised to 6 meter per second. Very simple to find. Just you find and check it whether it will get the value 1.094 into 10 raised to 6 meter per second or not. See here, orbital velocity of the electron in an second orbit is this much. What they are asking after this? They are asking to find frequency. They are asking to find frequency. So how to find the frequency of the revolution, frequency of the revolution of the electron in the second orbit? To find the frequency of revolution of the electron in the second orbit, so we have one simple relation. So what is that simple relation? V is equal to 2 pi r divided by t. V is equal to 2 pi r divided by t. V is equal to 2 pi r divided by t, or this I can write it as 1 by t is equal to 2 pi r divided by V divided by 2 pi r. So this I am going to write it as what? V is equal to 2 pi r by t. I want 1 by t because what is 1 by t? That is new frequency. So that frequency is equal to what? 1 by t, and this 1 by t from this equation. See why I have used this equation means, so electron is revolving with an orbital velocity. So therefore distance travelled by the electron for a one complete oscillation, or that is one complete circular motion, that will be 2 pi r divided by t, the time taken to complete its one revolution, that is nothing but t. 1 by t gives frequency. I want to find frequency of revolution, where? In the second orbit. This is very important. So nu is equal to 1 by t. So generally 1 by t is nothing but frequency, therefore 1 by t V divided by 2 pi r. So we know V. What is V? This V2. Why I have to write V2? Because I have to require the speed orbital velocity in second orbit. Therefore V2 is equal to 2 pi r2. Yes or no? Because radius of the second orbit is required. First orbit is given here. So therefore V2 by 2 pi r2. V2 is here. So value of 2 pi r2. Now comes the question r2. R1 is given. We know that the radius of the orbits are proportional to the square of the natural numbers. So from the concept of radii of stationary orbit, we come across one simple relation between radius and radius of the orbits with respect to the number of orbits. So we know that as the radius, as the number of orbits increases, the radius also increases. So therefore r is proportional to n square. See, for first orbit it will be nothing but 1 square. For second orbit is how much it is? R2 is equal to what? 4 times of R1. R2 is nothing but 4 times of R1. Yake? See here, you know that R1 is proportional to what? 1 square by some constant factor. So therefore, R1 is equal to K times of 1, that is 1. Say R2 proportional to 2 square, R2 is equal to say constant by 4. So therefore, R2 is K into 4, that is 4K times of what? R1. So this is K uncovered. So therefore this I can write it as what? R2 is nothing but 4 times of R1. R2 is nothing but 4 times of R1. So since R1, R is proportional to n square, this implies R2 is equal to 4 times of R1. R2 is equal to 4 times of R1. So V2 1.094 into 10 raised to 6 divided by 2 into 3.14 R2, that is 4 into 0.53 into 10 raised to minus 10 meter. So if you go on simplify this, you are going to get frequency nu is equal to, I have solved it, and the value of frequency is found to be, that is 8.213 into 10 raised to 14 hertz. So ನೀವು ಇದನ್ನು simplify ಮಾಡ್ರಿ, you are going to get this value. And remember, R1 0.53 they have given, but actually I require R2 for second orbit. Radii of this second orbit is required, but we know that how to get it. Simple relation, since R is directly proportional to n square. So directly proportional to n square, as the orbit number increases, so radius of the orbit is also go on increases by some constant factor. So that is nothing but R. Therefore R1 is proportional to, say R1 is equal to, say the what it becomes, some constant into 1. So therefore it is equal to K. Say therefore R2 becomes what? R2 proportional to 2 square. If I say R2 is equal to constant by 4. So therefore R2 becomes what? What is this constant? That is R1, 4 times of R1. So this is the thing. So with the help of all this equation, if you simplify, you will get this. If possible, you note down this and you try to solve. So we shall go for next problem. A hydrogen atom absorbs energy. So next problem. See second one, a hydrogen atom. So hydrogen atom 1, Z is equal to 1, atomic number 1. A hydrogen atom absorbs energy such that transition occur from first orbit to the fourth orbit. So there is an hydrogen atom. This hydrogen atom is absorbing the energy from first orbit, thereby it is going to transist to the what? Fourth orbit, that is N1 is equal to 1, N2 is equal to 4. Why N1 is designated as 1? Because the lower orbit, innermost orbit is the lower orbit, that is first orbit will becomes the 1 here. So second orbit is nothing but the what? For which orbit it is jumping, that is N2 is equal to 4. So fourth orbit. So a hydrogen atom absorbs energy such that transition occur from first orbit to the fourth orbit. If ionization potential of hydrogen, if ionization potential of hydrogen is, so it means if ionization potential of hydrogen is 13.6 electron volt. 13.6 electron volt. Fine. If this is the data, they are asking you find energy absorbed in the transition. They are asking you to find energy absorbed in the transition. Energy absorbed in the transition, number one. And the second one, they are asking you to find wavelength of the radiation emitted. Wavelength of the radiation emitted. Wavelength of the radiation emitted. So lambda we have to find. Lambda, here E, energy. Very simple. So this problem is based on Bohr's third postulate. When an electron jumps from a higher orbit to the lower orbit, fourth to 1, because fourth to 1, and even it is gone from first to fourth. This is called excitation. This is called excitation, and it is coming to its ground state. While exciting from 1 to 4, it absorbs some energy. So what is that energy we have to find? What is the energy absorbed in the transition? So we know that the energy absorbed in the transition is equal to energy difference between these two states, E4 minus E1. Yes or no? And remember, when it comes from 4th to 1, whatever the energy it absorbs, it gives out same amount of energy. So even energy emitted will be what? H nu, and this H nu is E4 minus E1. But they are not asking here emitted energy. They are asking absorbed energy, that is E4 minus E1. E4 minus E1 is equal to H nu, so that will be the amount of energy absorbed, and that the same amount of energy only they get emit. So during their emission, they are asking you to find wavelength. So if this is the energy associated with the radiation H nu, so this H nu can be written as what? Hc by lambda. So therefore, very simple problem it is also. We shall see the solution of it also. So ಈ ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ತಿಳ್ಕೊತೀನಿ. ಸೊ ಇದು ಬೋರ್ಸ್ ಥರ್ಡ್ ಪಾಸ್ಟುಲೇಟ್ ಮೇಲೆ ಇದೆ ಈ ಪ್ರಾಬ್ಲಮ್. ಬೋರ್ಸ್ ಥರ್ಡ್ ಪಾಸ್ಟುಲೇಟ್ ಮೇಲೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ವೆರಿ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್, ಇಲ್ಲಿ ಡಿಫಿಕಲ್ಟಿ ಏನಿಲ್ಲ. ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಯು ಟು ಫೈಂಡ್ ಓನ್ಲಿ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ಡ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ಡ್ ಇನ್ ದ ಟ್ರಾನ್ಸಿಷನ್ ಫ್ರಮ್ E1 ಟು E4, ಫೋರ್ತ್ ಆರ್ಬಿಟ್. ಸೊ ಎನರ್ಜಿ ಆಫ್ ಫಸ್ಟ್ ಆರ್ಬಿಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಫೋರ್ತ್ ಆರ್ಬಿಟ್ ನಮಗೆ ಕೊಟ್ಟಿಲ್ಲ. ಬಟ್ ಯಾವ ಆಟಮಿಗೆ ಹೇಳ್ತಾ ಇದ್ದಾರೆ? ದೇ ಆರ್ ಟೆಲಿಂಗ್ ಫಾರ್ ಹೈಡ್ರೋಜನ್. ಇಟ್ ಈಸ್ ವೆರಿ ಈಸಿ ಟು ಫೈಂಡ್. ಸೊ ವಿ ಶಲ್ ಸಿ ವಾಟ್ ಬೆಸ್ಟ್ ವಿ ಕ್ಯಾನ್ ಡೂ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್. See here, energy absorbed in the transition is equal to what? E4 minus E1, which is equal to H nu, which is equal to H nu. And remember, what is E4? E1 is given, Planck constant. Frequency is not given, fine. But how to find E4? That is very important. So listen here. For hydrogen atom, Z is equal to 1, and this N1 is equal to 1, N2 is 4, they have given. Okay, fine. So we know that energy of the electron in the fourth orbit is equal to minus 13.6 by N square, that is 4 square. We already calculated this. Energy of the electron in an hydrogen atom, nth orbit of the hydrogen atom is given by E is equal to minus 13.6 by N square electron volt. So this is for energy in an nth orbit. Navilli 1 anta substitute madidre first orbit minus 13.6 they have given here. Have given here. Ionization potential of hydrogen atom anta 13.6 anta kottidare. So therefore energy of the fourth orbit is very simple, that is minus 13.6 by, in place of n put 4, that is 16. So E4 will comes out to be minus 13.6 by 16 minus 0.85 electron volt, minus 0.85 electron volt. So we know that energy absorbed must be equal to what? E4 minus E1, that is equal to h nu. Since energy absorbed is equal to E4 minus E1. What is E4? Minus 0.85 electron volt minus of minus 13.6 electron volt, because E1 is minus 13.6. Ionization they have given, but energy is E1 is 13, therefore minus 0.85 plus 13.6 electron volt, 13.6 minus 0.85. So you will be getting that value 12.75 electron volt. This is the energy absorbed. And it is h nu, 12.75 electron volt. 12.75 electron volt. .75 electron volt. Next one, see what we have to find. Next one, we know that this must be equal to hc by lambda. This is 12.75 electron volt. See, we need wavelength also, wavelength of the radiation emitted lambda. So how to find wavelength lambda? Lambda is equal to hc divided by 12.75. We know that 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. So what about 12.75 electron volt is equal to? That is 12.75 into 1.6 into 10 raised to minus 19. So what is h? Planck's constant. So put that all the values here. So therefore lambda is equal to 6.625 10 raised to minus 34 joule second Planck constant into speed of light 3 into 10 raised to 8 by 12.75 into 1.6 into 10 power minus 19. Then lambda becomes, if you simplify this, the value of lambda is found to be 973 angstrom. 973 angstrom. Very simple problem. Simply they have given you to confuse this. Just minus 13.6 is the ground state energy. Energy in the fourth orbit is found to be, that is minus 0.85 electron volt. So if you take difference of these two, that will be the emitted energy, and emitted energy and absorbed energy are one and the same. So therefore this complete thing h nu equal to 12.75 electron volt absorbed, and this must be the emitted only. So hc by lambda. Under emitted condition they are not asking frequency, they are asking wavelength. So therefore I found wavelength. I found the wavelength 973 angstrom. Next, These problems are important because in the examination they are going to ask for 5 marks. All are previous yearly asked questions only. So next one, calculate wave number. Third one, calculate wave number, nu bar, wave number. Second one, wavelength, lambda, wavelength and frequency, of the first line of Lyman series. For what they are asking to calculate wave number, wavelength, frequency means for first line of Lyman series. You know already definition for Lyman series. It is one of the spectral series of hydrogen atom, and we observe this series of spectral lines due to the transition of electron from higher orbit to the first orbit. N1 should be 1, higher orbit should be 2, 3, 4, 5, like that. But in general they are not asking here, they are particularly mentioned about first member, which is to be chosen as first member here. So 2 to 1 is the initiation of Lyman series. Lyman series will begins from transition from second to 1. This is nothing but the what criteria, minimum criteria, that 2 to 1. So maximum will be infinity to 1 also. So therefore first line of Lyman series means 2 to 1. Respectively for other series also. For Balmer that is 3 to 2, first line. Okay, so here for first line of Lyman series, so what is the transition should be? N1 is equal to 1 and N2 should be what? That is 2. N2 should be 2. If this is the condition, they are asking calculate wave number. So we know that already the expression for wave number, nu bar is equal to 1 by, so nu bar is equal to what? 1 by lambda, and in general, see, nu bar is equal to 1 by lambda, and this 1 by lambda is nothing but r into 1 divided by n1 square minus 1 by n2 square. n1 is given, n2 is given, value of r that is 1.097 into 10 raised to 7 per meter, value of Rydberg constant. So therefore nu bar is equal to 1.097 into 10 raised to 7, 1 by 1 square minus 1 by 2 square. N1 is 1, N2 is, that is 2. This becomes what? You can substitute the r value at the beginning, or else first you simplify the equation. Hangadru madkolri. So r into, this is all 1 by lambda, r into 1 by 1 square minus 1 by 2 square, that is 1 by lambda, which is equal to r into nu bar 1 by 1 minus 1 by 4, 3 by 4. Therefore 3r by 4. This is 1 by lambda nu bar. So 3 into 1.097 into 10 raised to 7 by 4, 1 by lambda value, which is equal to nu bar value. So nu bar is equal to, if you simplify this much, you will get nu bar, you are getting nu bar value will be 8.228 into 10 raised to 6 per meter. ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ ನ್ಯೂ ಬಾರ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬರುತ್ತೆ ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ ಅಂದರೆ ನ್ಯೂ ಬಾರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 8.228 into 10 raised to 6 per meter. 8.228 into 10 raised to 6 per meter ಅಂತ ಬರುತ್ತೆ. ಇದು ವೇವ್ ನಂಬರ್, ವೇವ್ ಲೆಂತ್. We know that wavelength is reciprocal of wave number. Wave number is also a reciprocal of wavelength. So therefore, with this notation, what I can write lambda as 1 by nu bar. 1 by nu bar. First they asked about wavelength, we found. Next they are asking about lambda. So we know that nu bar is equal to 1 by lambda, therefore lambda must be 1 by nu bar. So therefore 1 by nu bar means 1 divided by that value. 1 by 8.228 into 10 raised to 6. So if you simplify this, you will get 1215 angstrom. Answer will be 1.215 into 10 raised to minus 7 you are getting. So if you shift the decimal places, then it becomes 1215 angstrom. Wavelength. Third one they are asking you, what's the frequency? Wave number we did, wavelength we did. The next we have to find frequency. Very simple relation. We know that nu is equal to c by lambda. We know that frequency of the light is equal to speed of light divided by wavelength. So here this wavelength of the Lyman series is 1215. So speed of light is 3 into 10 raised to 8. With this simple relation, 1215 into 10 raised to minus 10 here angstrom, that I have to convert into meter. Wavelength illide, ee value use madkolri. Speed of light is known to you, so nu is equal to, you will get it as 24.68 into 10 to the power of 14 hertz. This value is found to be 24.68 into 10 raised to 14 hertz. Next set of problem. These are not simply the problems that I am solving here. They are very important for the examination. Either they will ask one derivation for 5 marks, either they will split that 5 mark as one 2 mark question and another one is 3 mark question, or else they can put a single question of one numerical problem. Choices will be there, either 2 mark question, 3 mark question, or else full 5 marks one derivation, or 5 marks one numerical problem. So or else he may also give 1 mark sometime, 1 mark question also he is going to give. So that is the reason you have to concentrate. Even moreover, these type of set of equations of spectral lines are very important while solving some competitive examination questions. Next, third numerical is completed just now. Fourth one, the wavelength of the first line of Balmer series. They have given here wavelength of first line of Balmer series. The wavelength of the first line of Balmer series, lambda is equal to 6563 angstrom. 6563 angstrom they have given here. Then calculate wavelength of the first line of Lyman series. They are asking us to find what is the wavelength of first line of Lyman series. We just now only found what is the wavelength of the first line of Lyman series. That is 1215 angstrom. Yes or no? That itself is the answer. Not like that, we have to solve it. Okay, but I am telling you this is the answer. Because just now only in the previous problem what we did? We calculated first line of Lyman series based on the given data. For this problem, the data is simple. Wavelength of first line of Balmer they have given. 1st we shall judge which is the first line of Balmer series. first line of Balmer series corresponds to n2 is equal to 3 to n1 is equal to 2, because Balmer series definition is what? Transition of electron from higher orbit to the second orbit. So what is the minimum condition of transition for Balmer series? That is third to 2. This corresponds to even for H alpha. H alpha antanu helbodu. Even this transition 3 to 2 corresponds to what? Longest wavelength, that is a spectral line, shortest frequency, because they are very close orbits, third and 2, compared to the some other orbits. So therefore 3 to 2. So very simple, how to find this type of problem? They are very important. This type are very, very important for exams. Very simple also. See, wavelength of the first line of Balmer series is given. So therefore, Balmer series equation 1 by lambda is equal to R into 1 divided by n1 square minus 1 by n2 square. In general, this is the formula, empirical formula for finding wavelength. So 1 by lambda is equal to R into, what is 1 by n1 square? That is 2 square minus 1 by n2 square, that is 3 square in case of Balmer series. Therefore, 1 by lambda is equal to 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 R into 1 by 2 square 4 minus 1 by 9. Therefore, what it becomes? 5R divided by 36. So therefore 5R by 36 I can write here. ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿರಿ. 1 by 2 ಸ್ಕ್ವೇರ್ ಅಂದರೆ 1 by 4 ಆಗುತ್ತೆ. 1 by 4 minus 1 by 3 ಸ್ಕ್ವೇರ್ ಅಂದರೆ 9 ಆಗುತ್ತೆ. So what is the LCM of 4 and 9? 36. 9 minus 4, that is 5 by 36 into R, 5R by 36. This is all 1 by lambda is equal to. But what is the lambda of first line of Balmer? They have given. So what is that? 6563 angstrom. This implies 6563 into 10 raised to minus 10 meter. So therefore 1 by 6563 into 10 raised to minus 10. ಇವಾಗಾದರೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ರಿ, or else you keep this as equation number 1. I call this equation as 1. What they are asking? First line of Lyman. So which is the first line of Lyman series? First line of Lyman, n1 is 1, n2 should be 2. Therefore, for first line of Lyman series, n1 is equal to 1, n2 is equal to 2. That is 1 by lambda is equal to R into 1 by n1 square minus 1 by n2 square. This implies R into 1 by 1 square minus 1 by 2 square. R into 1 and 4. LCM of 1 and 4, 4. Therefore, this becomes what? 3 by 4, or else 3R by 4. 3R by 4, 1 by lambda. Dividing equation 1 by 2. I am going to divide equation 1 by 2. So if you divide equation 1 by 2, on dividing equation 1 upon 2, that's 1 by lambda. What is 1 by lambda for Balmer series? 6563 into 10 raised to minus 10. Minus 10 upon 1 by lambda ಅಂತಾಗುತ್ತೆ. Upon 1 by lambda is equal to 5R by 36 upon 3R by 4. ಏನಾಗುತ್ತೆ ಇವಾಗಿದು? lambda by 6563 into 10 raised to minus 10 is equal to 5r by 36 into 4 by 3r. R get cancelled. So therefore, 5r divided by 36 into 4 divided by 3r. So this becomes lambda is equal to 6563 into 10 raised to minus 10 into 5 4s are 20 upon 36 3s are. So that is 108. So if you simplify this, ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ you are going to get 1215 angstrom. 1215 angstrom. So ಈಗ ಇಲ್ಲಿ first member of Lyman series we found as 1215 angstrom. The data is only they have given first member of wavelength of the Balmer series. So like this you can also take your own assignment. How? If first line of Lyman series, the wavelength of the first line of Lyman series is 1215 angstrom, then calculate the wavelength of the first member of Balmer series. So like that first member of bracket series, first member of Passion series, first member of P-Fund series. So like that we can make some, for one single problem we can create the what? Some 10 to 20, 22, that is 30, 30 to 40 like that. Only just by varying the datas. So like that. So this is about the numericals, and in our next class we shall proceed the numericals once again. Okay, thank you.